So for today, we are going to talk about graphs of exponential, or not exponential, of quadratic functions. No more graphs of exponentials for right now. Graphs of quadratic functions, and we're actually going to see our first quadratic function. So in the work that we did last week, we saw quadratic patterns, but we didn't actually see any quadratic functions. So the first form of a quadratic function that we're going to look at is what's called vertex form. The nice thing about vertex form is that we're actually semi-familiar with this format for a function. It looks a lot like when we were talking about transformations last semester, and then when I gave you guys that sort of transformation review assignment in our last unit, okay? So we see this value in front. If it's negative, it's going to flip our graph. If it's a number bigger than 1, it's going to stretch us out, make it kind of taller and narrower. If it's a number less than 1, it's going to compress or kind of smash it down, flatten it out. This number in parentheses with x is going to be a shift left or right. This number at the end of our function is going to be a shift up or down. If you remember from our exponential graphs in our last unit, this guy was the asymptote. Our asymptote sort of default position was at 0, but if we had +2 here, we moved up 2. If we had -4 here, we moved down 4. We saw the same properties with our exponential graphs. We're going to see them here with our quadratic functions as well. So the graph of a quadratic function is called a parabola. So if I graph plain old x squared, we saw this in our transformations of functions unit last semester. If I graph plain old x squared, then I would get something that looks like this. This point right here, this sort of minimum, is called the vertex of our parabola. And in our parent graph, it's at 0, 0. The next nice points on either side of this parabola are up 1 and out 1. So I've got a point at 1, 1, and then over this way at -1, 1. And parabolas have this property that they're symmetric. So I can cut this graph exactly in half. And if I took this side and folded it over, this point would match it perfectly with this point. This whole half of my graph would match it perfectly with this half of my graph. The parabolas are symmetric. That will be a really convenient property for us later. This is my parent graph. If I make changes to this function, I'm again going to see changes in this graph. Okay? We call this format of our quadratic function vertex form because where I can see those left, right, or up, down shifts change where my vertex is and actually tell me exactly where that vertex is going to be. So I can actually, we'll see this in a few minutes, pick out the vertex of my parabola without even having to graph the function. I can tell directly from the function. So let's take a look at a couple examples. For our first example on page 4, here's our function. I'm not stretching or compressing or flipping because I don't see anything in front here, but I am going to move left, right, and up, down. So this -1 here in parentheses at the x tells me that I'm going to move to the right 1 spot. And then this +2 at the end tells me I'm going to move up 2 places. So from our parent function, I expect my vertex to be at 0, 0, but I'm going to move to the right 1 and up 2. Since we're not stretching or flipping, anything like that, that means that I can get my other 2 nice points the same way I got them from my parent graph. So from the vertex, I'm going to go up 1 and out 1 on either side. So up 1 and out 1, and up 1 and out 1. And there's my parabola. There's my graph. My vertex for this function is at 1, 2. And I want you to notice that I see 1 and 2 in my function. Questions on that first example? Okay, let's look at our next one. So we've got x plus 3 squared minus 2. Nothing in front, so we're not compressing or stretching or flipping. I'm going to move to the left 3 and down 2. So my vertex should be at 0, 0, but I'm going to move it left 3, 1, 2, 3, and down 2, 1, 2. And then since I haven't changed the shape of this, I haven't stretched it out or anything like that, to get my next nice points, up 1 and out 1. There's my parabola. Its vertex is at -3, -2. And again, notice that I see those values in my function. Questions for me so far? Okay. On the next page, we're going to do some more practice with our vertex form functions and graphs. Now I'm seeing some changes to the shape of my function with these. So for number 1 on page 5, we've got 1/2 as our lead coefficient as our A value. That means that we're going to compress this graph. It's going to be kind of flat, it's kind of smashed down. So we're going to compress. And then this plus 3 here is going to move us to the left 3. And then -2 will move us down 2. Since I'm moving to the left 3 and down 2, I know just from my function that my vertex is going to be at -3, -2. Left 3 and down 2. I'm moving back 3 and down 2 from the origin, from 0, 0. That means my vertex will be at the point -3, -2. So 1, 2, 3, 1, 2. And then because my lead coefficient is 1/2, instead of going up 1 and out 1, I'm going to go up 1/2 and out 1. You can also find more points on this graph by picking a value for x and plugging it in. So if the transformations are a little tricky for you, remember you can always graph a function by making a table. We talked about this with our exponential functions. You can still do it for your quadratic functions. You can always make a table. So let's say I wanted to know if I plug in -1 for x, what do I get? That would be 1/2 times -1 plus 3 squared minus 2. So following order of operations to find my y value, this would be inside parentheses 2. 2 squared is 4. 1/2 of 4 is 2, and 2 minus 2 is 0. So I'd have the point -1, 0. And then again, the nice thing about parabolas is that because they're symmetric, I would also get this point. Here's my graph. Let's take a look at number 2. For number 2, our lead coefficient is negative. So that means our graph will be flipped upside down. So instead of opening up with this sort of U shape, we're going to open down like an umbrella. This +1 here means we're going to move, oh, hang on, I forgot about the 2. So the negative is going to flip us, but then the 2 is going to stretch this and make it taller. +1 is going to move us to the left 1. And then +2 is going to move us up 2. My vertex, which I can identify right now, would be -1 plus 2. Just like with our transformations, when it's right next to the x, in parentheses with the x, it kind of goes the opposite direction of what I would think. So +1 actually moves us back 1 spot. The same is true when I'm picking out my vertex from a function. I get the opposite sign for whatever number's in parentheses with x, and then the same as whatever's at the end is my y value. So as I go to graph this, my vertex is at -1, comma 2. And then our graph is flipped. So again, instead of opening up with this U shape, we're going to open down like an umbrella. And then we're stretching by 2. So instead of going up 1, out 1, I'm going to go down 2, out 1. Down because we're flipped, and 2 because I've got that 2 coefficient there. We're stretching. Questions on number 1 or number 2? Okay, let's look at number 3. I have a negative sign in front, so we're going to flip this graph again. +1 means we're moving to the left 1. And then +4 means we'll move up 4. My vertex would be -1, comma 4. Opposite sign of what's in parentheses with x. And then here's my y value. So -1, 1, 2, 3, 4. And then our graph is flipped, but it's not stretched or compressed. So down 1 and out 1 to get those next nice points. Any questions on number 3? Okay, number 4 looks a little different than the other functions that we've seen. I don't see x in parentheses with anything. What's the only thing I could have put in parentheses with x that I wouldn't have to write? 0. This would have to be a 0. So that means that my vertex is at 0, comma -4. So we haven't moved left or right at all. We have a 2 as a lead coefficient. So we are stretching this graph. And then we're moving it down 4. But no left or right translation. So my vertex would be at 0, comma -4, 1, 2, 3, 4. And then we're stretching it by 2, so up 2 and out 1. Questions for me on number 4? On the next page, the first couple of problems that we're looking at, this time we have the graph and we want to write the function. So for the last several examples, I picked the vertex out of the function. Okay? For vertex form, I can see the vertex directly from the function. So what I'm going to do now is sort of the reverse of that. I'm going to pull the vertex from the graph. So for this first graph, we're at -2, comma 1, 2, 3. And now I'm going to put that vertex into our function. So I know that x coordinate goes in parentheses with x, and it's going to have the opposite sign of the actual coordinate. So this would be x plus 2 squared. And then my y coordinate goes at the end exactly as it is. So since I have +3, I'm going to put +3 at the end. Now I'm going to use the shape of my graph to determine what, if anything, goes in front of the x parentheses. So I expect my parabola to open up like a U. This one's opening down like an umbrella. So that means that I flipped it, and I've got to have a negative lead coefficient there, a negative sign in front. I want to check to see if I compressed or stretched it at all. So I see from my vertex to the next point, I've gone down 1 and out 1. The down, again, reinforces that I flipped this, but since it's 1 and 1, I haven't stretched or compressed it at all. So this is my function for this parabola. I've got the vertex here and a negative in front because it opens down. Questions on 5? Okay, let's take a look at 6. Same idea. I'm going to start by picking out my vertex. So my vertex here is at 1, comma 1, 2, 3, -3. So I would have y equals x minus 1 squared minus 3. I'm opening up like a U, so I haven't flipped this. And to get from the vertex to the next nice point, I go up 1 and out 1. So I also haven't stretched or compressed it. So this is my function that describes this parabola. Questions on number 6? Okay, the last thing we're looking at on the bottom of page 6 is some matching. So we have 4 functions and 4 graphs, and we want to determine which ones match. So as I look at each of my functions, I can see that I'm going to have some different vertices here and some different changes to my graph. If we take a look at number 7 together, I've got a vertex at 0, negative 2. And then my lead coefficient of 2 tells me I'm going to open up and I'm going to be stretched. Which of our graphs meet all of those criteria? Vertex at 0, negative 2, we open up and it's stretched, sort of narrower in here. B, yeah. Vertex at 0, negative 2 opens up and we're kind of narrower. So that's the function for graph B. I would like you now to try 8, 9, and 10. Match them to their graphs. Which graph matches the equation for number 8? D, our vertex would be at 0, negative 2. We're going to open up, but this time we're going to be wider. That's D. How about number 9? C, we're going to be flipped because of that negative in front. We're going to be wider, but our vertex this time is at 0, 2. So that's C. And then 10, A. We're going to be flipped. We're going to be narrower, and our vertex would be at 0, 2. So that's A. Questions for me? Okay, so that's vertex form. This is our first form for a quadratic function. We're going to see other forms for quadratic functions starting tomorrow. And those alternate forms or formats for our functions show us other important information. So vertex form shows us the vertex. We're going to look at some other forms for quadratic functions that show us other, again, sort of key features of our graph, other important information. For the rest of class today, you have an assignment on delta math that's going to review this same stuff. Okay, so what's the vertex? If I have this function in vertex form, what would I expect the graph to look like? What is the vertex from the graph? Or what's the vertex from the function? Or if I have vertex form, graph to function. All the same stuff that we did today, okay, is in your assignment on delta math. So that's what I would like you to work on now.